Welcome to another great O'Reilly webcast. My name is Yasmina Greco. I'm with O'Reilly Media, and I will be your host for today's event. Today, folks, we have Tammy Everts with us, and she is going to talk to you about, can third-party scripts take down your entire site? Tammy is a performance evangelist at Radware. She inhales data, she exhales reports, blog posts, and random tweets. We're very excited to have Tammy with us today to present this webcast for you all. As we get the event started, I'd like to go over a little housekeeping to help you get the most out of today's webcast. First, you'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Tammy. We find that our audience usually has a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Tammy, please preface them with a capital letter Q so we know that they're for her and we can make sure we see it for Q&A. You can also open, move, and resize any of the other widgets. If you would like to tweet from the Twitter widget today, you might need to give it permission to access your account. The Twitter widget will automatically append the event's hashtag to your tweet so you don't have to. And today, folks, our hashtag is VelocityConf, all one word. If you have any trouble with the webcast, please take a look at your help widget. If you continue to have trouble, just post it in the group chat and one of our staff will help you right away. If you have choppy audio or stalled visuals, please try refreshing your window. Also, we'd like to let you know that we are recording today's webcast, and we will have the archive ready usually within 48 hours. And folks, at this time, it is my pleasure to turn the program over to Tammy for her presentation. Hello, Tammy.
Hi there. Hope everyone can hear me. So I am a performance evangelist at Radware, and what that means in day-to-day terms is that I take a very user experience oriented approach to thinking about performance, and I direct all of our research in that area. And it basically, as Yasmina said, exhale reports and white papers and blog posts, etc. I would love to have questions, as many questions as you can throw at me. How I'm going to be dealing with questions is just put them in the Q&A and preface them with that capital Q, as Yasmina said, and I will be setting aside time at the end of this session for answering those. So today, I want to talk about a topic. Every time I write about third-party scripts, people always really respond to these posts, and I think because there's this general sense that it's a bit of a Wild West sort of scenario when it comes to third parties. And a lot of people, even people who are pretty hands-on with their site, have this feeling that they've lost control over what's even on their pages and what impact these scripts can have on their pages. So what I'm going to be covering today is kind of a high-ish level understanding of third-party scripts, how to begin to wrangle them. I won't be going into super hardcore performance geek speak, although I will be alluding to that and providing the resources that will let people who are interested in getting a deeper dive take that. But really, if you have a gut feeling that third-party scripts are an issue on your site, you're not sure what to do next about it, then this is the session for you, I hope. So let's get started. So we have a love affair with third-party scripts, and sometimes the response whenever I write about it is people are like, oh, I hate all this stuff. Why is it on my pages? Why can't my pages just be small and have less content and then the world would be perfect? Well, there's a reason why we have these scripts. They increase conversions. If you've got third-party ads, they're bringing in ad revenue. If you're using social widgets or other social analytics, it's possibly increasing your page views. You're gathering visitor data. And also, I mean, there's reasons as developers to embrace third parties. You're not having to build something from scratch. It's just quick and easy, single line of code. for better or for worse. Generally, these are established providers with established, like tested scripts, and you have a community of support both with the provider and with other users of the script. So there are a lot of really compelling reasons why we have embraced third-party scripts. I think that something that has come as a surprise to everybody, including me, is just how quickly that embracing has taken off. A couple of years ago, we did an audit of the top 100 e-commerce sites, and we found that the average site contained 7 third-party calls, and maybe a typical site would contain about 25 requests for third-party scripts. Nowadays, third-party calls can make up to even more than 50% of a page request. That's some really interesting stuff from a presentation by Steve Satters a little while back. I just want to point out, you'll notice that everywhere on my slides where I'm citing research, I provided the link so you can go and chase that down and get a bit of a deeper insight. So what do we mean when we're talking about third-party calls? Commonly, we think that we're talking about, if you ask somebody, what are your third-party scripts, they're going to say, oh, it's Facebook, it's Twitter, it's Google+, it's Pinterest, it's all the sharing buttons. That's actually just the tip of the iceberg. If you actually look at the broader landscape of third-party calls, you see that this is a slide, actually it's about a year old, from Lumascape, where they identified or attempted to identify all of the main marketing technologies that are available out there. Now this graphic, not everything in this graphic is a third-party script, but a lot of them are. And it just gives you an idea just how vast this world has become. Third-party APIs, ads, tracking beacons, analytics. So really those social buttons that everybody complains about are just a tiny, tiny tip of the iceberg. And as I said, the question is, are there too many third-party scripts? Well, that's kind of what this session is intended to answer. Just, do you know how many scripts are contained on your page? And are they all actually necessary? Are there any that are redundant? Are there any that you should kill? Really, what I want you to take away from this session is that it doesn't matter how well you optimize the rest of your page or the rest of your site if a single line of external JavaScript can take out the entire thing. So third-party scripts present what I think is the 3 main risks that they present are outages, slowdowns, and potentially even security risks. And I'm going to go into each of these in a second. So outages. Every third-party script, every third-party provider goes down at some point in time. There is no provider out there who can give you a rock-solid 100% uptime guarantee. It's like the laser shooting unicorn that you see on your screen. What you ideally want to get is providers that can give you like up to 99.9% of uptime, but that 100% is completely elusive and unrealistic. This is a headline from a couple years back when Facebook outage didn't just slow down sites, it actually prevented some sites from loading completely. And just by virtue of the fact that they had these sites had interconnections with Facebook's Connect app and the Facebook like button. Now, I'm not picking on Facebook today because actually in terms of being on third-party performance, they're really on it, and I'm going to talk about that more later on. But I just mentioned this to just highlight the fact that even a huge third-party provider goes down. They make headlines. All the smaller providers do not. So in terms of other than outage, what do third-party scripts do to your pages? Well, they increase your page weight, they make your pages bigger, they increase the number of hosts and the number of connections that you have to maintain with all those different providers, and they introduce latency. And I'm going to talk about that more in a second as well. Just to illustrate that, a while back, New Relic, a performance monitoring company, looked into the most popular third-party APIs being used by the 200,000 plus applications that it monitors, and they calculated the average response times for some of the most popular scripts out there. And these ones right here, the Twitter, Facebook, and PayPal scripts, these are actually some of the faster ones. So if you're using any of these scripts, and again, this data is a little bit old, but these are some of the better ones. This is just to show you the type of latency hit that every third-party script is capable of introducing to your pages. So let's talk for a second about security. A while back, we coined the phrase fourth-party call. And a lot of people were like, well, what the heck is a fourth-party call? Like, I barely wrapped my head around third parties. So what is this new thing? And what a fourth-party call is, or what we call a fourth-party call, is when you insert a third-party script into your page, and usually it's some kind of tracking beacon or something like that. And not all tracking beacons do this, but some do, and you need to be mindful of this. That start a cascade of fourth-party calls that you, by inserting this code in your page, have unwittingly authorized to a number of other sites. So in one example, we did a waterfall of what the number of fourth-party calls that a single third-party script triggered. This is a waterfall of that. This one third-party tag, and I'm not going to say which one it was, triggered 49 different server calls, 49 different third-party requests, calls that the site owner did not knowingly authorize to various fourth-party servers. And of these 49 fourth-party calls, 21 of them are redirects. So those are the ones that you can see. They're indicated by the red dots in the middle column. And so, as we all know, or most of us will know, the result is that this ping-pong effect as each redirected call ricochets from server to server, load time, delaying the page. Sorry. There we go. And wasting load time. And every one of these fourth-party calls is over SSL, which also has cumulatively a really significant impact on load time. So in this particular instance, we calculated that all of these fourth-party calls added 1.8 seconds to the page's load time. Again, that's just from one third-party script of what could have been, dozens on the page, and a page that contains 80 or 90 other resources. So that single line of code isn't a simple line of code. Sorry, there we go. So the genie's out of the bottle. Third-party content is here to stay. It's not going to go anywhere. It is that stat that I cited earlier about 50% or more of pages requests coming from third-party calls. We could see that increase even further. It's a bad idea to underestimate the ability of very, very determined marketing technologists to develop new scripts that will introduce really nuanced insight into your pages. So now I'm going to walk through this 11-step process for getting a handle on your scripts. So if you're not already conducting regular audits of your site's third-party content, you should be. Perhaps, if you already are doing this, you're doing it through your whatever APM or RUM solution you're using to track your performance of your pages in real time. But if you're starting from scratch, this is a process that you can follow. Okay, so what you want to do is you want to identify all the third-party scripts. You want to know which pages they're on. You want to identify what type of performance best practice each script is using, and I'll be going into these best practices later on. Or if they're not using any best practice at all, and then how can you remediate that? And then you also want to be really familiar with the service level agreement for every third-party provider that you're working with. Now, I'm going to talk about SLAs a little bit later. I find it's actually really rare for a third-party provider to have a particularly meaningful SLA, but if they do have one, I think that's a great first step. So, and if they don't have one, that's something you can ask for. So the first step is getting a waterfall chart of your pages. And throughout this demo, I'm going to be using TechCrunch as my subject. The reason why I've chosen TechCrunch is because it's a media site. I know that it will have a lot of third-party scripts on it. Because I chose TechCrunch because it's actually a really good media site performance-wise. It's relatively incredibly fast. And I assume that it will probably not be as riddled with third-party single points of failure as other media pages. My goal here is not to embarrass anybody. It's to highlight a really good site that, like most sites, is probably going to have a couple of third-party issues that we can easily identify and talk through. So I went to web page test. Just entered TechCrunch, and this is the page that I got, that you get back. And if you're not familiar with web page test, I'll give you a little bit of the lay of the land here. This is the initial results page that you get. As you can see, as I said, the TechCrunch page the home page is pretty fast. Complete load time in less than 5 seconds, which is great. Start render in just over 2 seconds, which is pretty good as well. If you want to take a deeper dive into waterfall charts, I wrote a post a while back just called Waterfalls 101, and there's a link at the bottom of this slide for it gives a really, I think, a fairly comprehensive overview of just how to introduce yourself to waterfall charts and how to interpret them for your pages. For our purposes today, I'm going to move right to the waterfall that I generated for TechCrunch. So what a waterfall chart does, it gives you a bird's eye view of how your page loads. It lists all your resources in the order that they're called from top to bottom. And it also lets you see from left to right the cascade effect as objects are rendered in the page. So the dark green line, the first vertical line that you see, shows when the page starts to render. The bright green line, which is a little bit to the right of that, shows when content first starts. And further to the right, it shows when document complete. That's basically when something called the onload event is fired, and the page and that's what most performance measurement tools use to indicate that the page is loaded. And then the far right is when the page is completely loaded, like everything that's kind of loaded after the onload has arrived. Just as an aside, when you're looking at waterfall charts, right now, all we know in terms of measuring the best possible user experience is that the primary content for the user loads somewhere between that bright green line and that blue line, but it varies from page to page. It's a really difficult metric to gather because every page is different. So I'm just putting that out there. So we know that, what we know looking at this page is that about half of the page's resources are loading before we get to that bright green line, and then about half of them are loading after the bright green line. And then you can see the bottom dozen resources are loading to the right of the blue line, which are loading after the onload. Now, the red arrows that you see with this graphic demonstrate where a bunch of the pieces of third-party scripts are located. I actually kind of just realized my arrows were going to just be everywhere, but there's even more third-party content on this page than I'm indicating. So you can see where we get that 50%. It's really easy to come up with that 50% number. And you can see that a number of third-party scripts loading before the page has started to render and before the page has started to page in the browser, and a number are loading after document complete. And then just so you understand what each of the bars is doing, if you look at an individual bar, you see a little dark green line. That's your DNS lookup. Orange line is when the TCP connection takes place. Bright green is time to first byte. And then the blue section of the bar is content download. So that's a really quick explainer for waterfalls. But as I said, if you want to know more, I recommend going and checking out that blog post. So now you've identified all the third parties on that page. We haven't. If you're not sure if a line on your waterfall is a third-party script or not, the way to do it is to just go into the waterfall itself, like in web page test, click line item, and then you'll see this pop up, and it will give you information about everything about the script in terms of metrics like, how long it takes to negotiate SSL, time to first byte, and you'll also see that third piece is the host, who is actually hosting the content. And so third-party script, anything that's hosted by somebody else, that verifies that this is a third-party script for you. So if you audit all your third-party scripts on your pages, then the next step is you want to test your pages for existing single points of failure, this third-party SPOFs. And I didn't coin that phrase; somebody else did, but it's a handy phrase. So third-party SPOFs, we used to test for them in this very painful way, and I've included the link here if you're curious to know how to do it. That involved going through the waterfall and manually highlighting all the third-party scripts, and then using web page tests to black hole those scripts and see what came up. But there's a better way now, thanks to Patrick Meenan, who is a software engineer at Google. Patrick also developed web page tests. So he developed this tool that works in conjunction with web page tests. It's a free tool. Unfortunately, it's only for Chrome. It's a Chrome plugin called SPOFomatic. And it's just a browser extension. You install it, and it helps you to identify in real time third-party SPOFs for any page you happen to be browsing via Chrome during your time on the web. So this is what it looks like. I can call your attention to the top right corner of this screen grab. You'll see a little circle with the triangle with the exclamation point and the red 2 in it. That's what the widget looks like in the browser. And anytime you see the little exclamation point, you know that you're on a page that has a potential third-party SPOF. So doesn't necessarily have one. It just has the potential for one. And so again, we're going back to TechCrunch and using it as our test subject. We see that there are SPOFs, potential SPOFs on this page. So click on that icon, and we see what the hosts are. Optimizely, your Google fonts, and Twitter are three SPOFs potentially that exist on this page. So now, this is a great shortcut again that the tool does for you, is you can see a text link that says generate SPOF comparison video. And what this lets you do is it uses, again, web page test, and it's going to generate a video that will show side-by-side comparison of how the page loads normally and then how the page loads if we black hole that third-party content. Basically, if we simulate what would happen if each of those 3 third-party providers went dark. Let's see. Okay, so this is just a screen grab. I'm going to push out the URL for you. There you go. So this should launch the link in your browser. And if you are not seeing the link, I'm just going to go straight to the next screen, where another really good feature of web page tests is that it lets you generate videos, but it also generates film strip views of the video. So what you can see here is side by side the original page at the top, and you can see where, with by screen grab number 6, by frame 6, the original page has started to download. So that's around 3.5 seconds. And with all the content black holes, you can see that the SPOF page takes 22.7 seconds to finally even start to render and load. So it just takes that long for the page to resolve and finally decide to load in the browser. So not good. We have a problem. So the next step is we want to isolate what are the problem scripts. We know that it's at least one of the 3 scripts that were identified by SPOFomatic. So we go back to that and we look at what those scripts are. So cdn.optimizely.com, fonts.googleapis.com, or platform.twitter.com. So with the first one that I'm going to hone in on is the Optimizely. And if you're not familiar with Optimizely, it's a good tool. It's basically A/B testing software, not performance testing software, but software that lets you just do A/B testing on your pages, various different permutations. And so let's go back to our waterfall and check out where that script appears. So we can see here that it's it's near the very top of the page. It's the second request on the page. And we can also see other metrics like the timing and like the file size. So we see that, lookup 56 milliseconds, not bad. Initial connection 33 milliseconds, pretty good. Time to first byte 37 milliseconds. All the rest is not bad. Content download 435 milliseconds. Okay, well, that can be dependent on, it could be a browser issue. It could be to do with just the complexity of what TechCrunch is asking the script to do for it. And then interestingly, I want to call your attention to the file size. So we see that it's 43 kilobytes. And I think in our world, it's really easy to look at 43 kilobytes and think, oh, well, that's nothing in the grand scheme of things. We live in a world now where, a typical e-commerce page is at least 1 meg in size, and it's not surprising anymore to see pages that are 2 or 3 or 4. I've even seen pages that were 5 megs in size. But I do want to mention that if we are also in a world where 30 or 40 or 50 of the calls on a page are third-party scripts, and we multiply that by 30 or 40 or 50 kilobytes per call, that really adds up. That's a really significant number. And so I just don't want us to fall prey to just sweeping those, a few dozen kilobytes here and there under the rug. In the world that we live in now, every kilobyte really does count. So so what we're going to do now is get a little bit more manual, highlight the host name, cdn.optimizely.com, and go back to web page test. And so this is a really cool feature of web page test. If you want to just focus on a single host, you go to web page test, the main page, put the URL in, and then click on the SPOF tag, and then you enter that one host. And again, we're going to generate a video, and I'm going to push that out to you to check out. And give you a second to look at that. And if you would rather just check the video out later, or the video is not working for you, again, I've done a screen grab here, and you can see that for this page, we're looking at a serious problem. I'm just going to work my way back up here. Okay. There we go. Sorry about that. This is the page that I want you to look at. So this shows that at least one of the performance culprits for the TechCrunch page was the Optimizely script. And so let's move on for a second, because now we want to actually look into, well, why is the script slowing down our page? What does Optimizely say or promise about how their scripts will perform? And because they are a conscientious provider of third-party scripts, they actually have this available on their site, and I provided the link below because it's actually part of a larger page, and you can check out what they have to say about security and other issues as well. And so they recognize that because their code has to load before the page, has to load at the top of the page, that they realize that it's critical to do everything within their power to make sure that the performance impact is little to none for your site. So they talk about the size of the code, how long it takes to load, where it's hosted. They talk about the fact that all the tracking requests that then go out from that piece of code will happen asynchronously, so it will happen in parallel with everything else that your page is doing, and that any images will not block page load. And they also specify that they do provide uptime monitoring for their site for certain levels of customers. So it's good to know. So, to my thinking, you have a good tool. You have, they're doing what they can. They're giving you the tools that you need to measure how they're performing. This is really about the most you can expect from a third-party provider. So I think, so when I felt comfortable bringing up Optimizely in this particular walkthrough, because I didn't want to embarrass them, and I did feel actually that they were really a good role model for other third-party providers. So now let's look at one of our other scripts, which was we're going to black hole Twitter and see how the page performs when Twitter is unreachable. So again, I'm going to generate a video, and it's going to you right now. And again, the slide, for those of you who are just following along with the film strips, you can see that there's a bit of delay to the full load time for the page, but Twitter is not actually slowing down any other aspect of the page. So it's being a good citizen. And then the third script that I experimented with was the Google font, and basically got similar results to the Twitter page, so I'm not bothering to show them to you here today. So in my travels, I find that this black hole test, generally I see negative results falling into three different camps. The first is when script failure results in the page loading slower than the original page, as you've seen. So what's happening is your page is calling for the script, the call is blocking the rest of the page from loading, and how you can fix this is by using a front-end optimization technique called deferral, where you defer the script to load after the onload, or by using an asynchronous version of the script if one is available, and I'll talk more about that later. The second camp is when the script failure results in the page loading faster than the original page. And I don't see this as often. I couldn't find an example to show you today, a current example. But what this is caused by is when the latency incurred by the script is hampering the current performance of the page. So your script is not deferred, it's not asynchronous, and because it's so slow to be called, it's yes. So it's basically hampering how so when you black hole the script, the page actually loads faster because you've gotten rid of actually a significant performance roadblock. So typically we see latency for desktop users in kind of the 65 to 145 millisecond range. So if you ditch a third-party script that has latency issues, you can expect to see that kind of performance gain. So you might want to, if this is happening, then you might want to talk to your third-party provider about where they're hosting their scripts or how they're hosting their scripts, or even if it's possible for you to host the script yourself somehow. And then the third result I see is just the script failure results in the page just timing out completely. And so that's just a more extreme example of number one, where the page loads slowly. So before you add a new script, it's really important, before you add any new scripts, I mean, you've gotten a beat on what you have already. I can't stress this enough. You really need to research the provider and go through a number of steps of homework before, during, and after implementation. Questions you want to ask them are, what is your typical response time and time to last byte? So how long does it take typically for the script to fully load? And Optimizely is a good example of that, where they give that kind of information. What's the response time and time to last byte for multiple locations? What is their average monthly downtime? You want as close to 100% as possible. Can they actually give you an uptime guarantee? Do they use a CDN? And if they do use a CDN, where are the CDN caches located? And that sort of relates to what I mentioned just a second ago about wanting to know how response time and other metrics measure from different locations. Next, we've sort of been over this, but you want to read the provider's service level agreement. So an ideal third-party SLA should, as I said, give you a monthly uptime guarantee, should explain in detail what tools they'll use for monitoring and reporting performance issues, and then actually let you know what's the process for reimbursing you or making some kind of remuneration if you're paying for the service, if uptime drops below the guarantee. Now, most third-party providers, to the best of my knowledge and experience, don't offer real-time monitoring of their scripts, and many don't offer particularly meaningful service-level agreements. And this isn't going to change until site owners start asking for these tools and explaining why it's really important for your business. Right now, whether or not the provider has an SLA might not be a deal breaker for you. The script might provide such huge value that it'll outweigh whatever nebulousness you have of not having an SLA. So you can choose to proceed, and then just accept the fact that if your provider isn't doing any real-time monitoring, then this is something you need to take care of at your end and be on at all times. So the next step, again, this is before implementation, is you want to perform a cost-benefit analysis. Like what kind, knowing in advance that every performance or every third-party script is going to have some kind of performance impact, even if it's just those niggling little bits of latency. You want to know that you're going to get some value out of it. So you want to perform some kind of cost-benefit analysis. I like A/B testing if possible. Perform an A/B test of your site with and without the tool in a real-world environment. So install the third-party script on your page and maintain the original page. Serve a small cohort of your traffic through the page with the script, the larger cohort through the page without the script, and actually just test it. See what impact the page has or the script has on your page. Generate waterfall charts for both tests and identify how long third-party objects take to load, and then note these benchmarks. And you can do for example, if you have a retail site, you can do kind of quick and dirty calculation on whether or not the script is going to pay for itself. So say from the tool vendor, you get the number for the average conversion rate increase that they experience by their other customers who use the tool. So, if they are providing a tool that promises increased conversions, they should have that number for you. And then if you use this widely accepted performance stat from Aberdeen that a 1 second page delay equals a 7% loss in conversions, you can actually use that to do, as I said, some quick and dirty math to calculate whether your conversion gain or whether you have a net conversion gain or loss after using the script. So just for example, say the script slows down your pages by 2 seconds. That's equals a 14% conversion loss according to the Aberdeen stat. But if that same tool tells you, the provider tells you that you're going to experience a 20% increase in conversions, well, then your net gain is 6%, not including the cost of purchasing the tool. So that's something that you want to, that's good to know. So you're not looking at this purely from a performance perspective, but also looking at it from a bottom line perspective as well. And the next step is, never a popular one, it's just be ready to say no. Nobody likes to be the bad guy. Nobody, it's always hard to resist, the siren song of the latest widget of the day. But if you can't prove that there's going to be any kind of ROI, whether it's social ROI or page views or revenue or what have you, then put your hands up and say, no, we need to actually make a better case for this before we can push it out to our site. So moving on to actual implementation. The easiest thing to do with third-party scripts is defer them whenever possible. And so let's get back to our waterfall where we identified all of those, well, not all of those, but a number of the third-party scripts on that TechCrunch page. So put in very simplest terms, deferral is a front-end technique. It delays the execution of non-critical scripts until the rest of the page is loaded and rendered on the browser. So what that means is you see that blue line, that blue vertical line. In an ideal world, purely from a performance perspective, if you could put all of your third-party scripts at the bottom of the page, so they're rendering after that onload event, that would be really super wonderful. It's not an ideal world, however, so we're going to. We'll talk about that for a second. It's easy, which is great. The downside of that technique is it really won't work for all content. Optimizely, it was an example of that, where that script needs to be at the top of the page in order to do what it's going to do for you. If your site hosts third-party ads, like looking at the TechCrunch page, your ad providers are not going to like it if their ads are loading last. They're going to want their ads to load first. You really want to save deferral for your invisible third-party scripts, like analytics beacons, your tracking pixels, social widgets. I mean, to my mind, I don't care if Twitter buttons and things like that load after onload. They're not essential. I'm not ready to even think of sharing anything within the first 5 or 6 seconds that a page loads. So those just don't need to be there right away. Just talking about ads for a second. I mean, this is something that when I was talking earlier about why you want to talk to your third-party providers about their SLAs and their uptime guarantees and that sort of thing. You want to have that same conversation with any ad providers that you're using. So if you can't use deferral, an alternative is to use asynchronous versions of the scripts. So I'll talk a little bit about what that means. So when we think about how pages load, really just sort of going back to that waterfall, resource sequentially. And even, some resources loading concurrently, obviously, some more than others, depending on which browser you're using. But it's really this kind of linear format. What asynchronous scripts let you do is load in parallel with crucial page content. So those scripts are just coming in when they're available. They're not blocking your primary content, and they're letting you display ads and all your other business critical scripts without blocking your page. And some examples, again, Optimizely, some other companies that are doing a really good job with making available async versions of their scripts are Facebook, Twitter, Google Analytics, Google+, those sorts of things. So it's something to ask your script providers. Do you have a third party, or do you have an asynchronous version of your script? And if you don't, why not? Will you, and just ask those questions. So the advantages of using asynchronous scripts are they don't block the primary content, but there are some difficulties as well. For one thing, it can be tricky to program, which is all the more reason why we should really appreciate and be gratified by the fact that async code has this increasing rate of adoption among third-party providers. But also, slow third-party scripts will prevent the onload event from firing. So that blue line, it will delay that onload event. So as I was talking about earlier, for performance measurement tools, the onload event defines load time. And so if you have scripts that are still underperforming but loading asynchronously, well, that's fine in terms of providing a better user experience, but it's going to mess up how you're doing performance measurement because you might not be aware of the fact that the script is taking 30 seconds to finally render in the browser. And if you've got this on thousands of pages, or you're tracking thousands of pages over a long period of time, and this delayed onload event, which is basically that's your load time being defined in all your reporting, will make it really, really difficult to pinpoint other performance problems. So it's just something that you need to be mindful of. It's great for scripts to be asynchronous. They still do need to be as responsive and quick to complete rendering as possible. So I said I wasn't going to get into a super deep dive on the code side of things. If you want to learn more about the asynchronous scripts and get some more backstory there, I definitely recommend, if you're not already reading Steve Souders' blog, reading everything he has to say, and also Stoyan Stefanov has written some very good things about it as well, and he is one of the developers behind the Facebook's asynchronous buttons, and he leads things over there. So the next step is you have installed, or you've implemented your third-party scripts. They're live on your site. Now you just need to monitor them constantly. After you go live, I can't say this enough, monitor, 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 and not just your third-party scripts, obviously, your entire page. If you can't measure it, you can't fix it. And if you're not measuring it, then you really just have no window onto what your pages are doing at all. These days, there's no excuse for not being able to monitor your pages. There are so many application performance management measurement tools, RUM tools at all price points, tag management systems just for just manage and monitor your tags and ensure that your third-party scripts are performing. SPOFomatic, I love it as a tool. Yes? I love SPOFomatic as a tool, but it really just gives you a keyhole view of performance. You really need to have that open picture window at all times. And if you can't convince your bosses right now to invest in a good monitoring solution, well, I do recommend using something like SPOFomatic to scare them straight and make them realize what they're risking by not actually monitoring what third-party scripts and other elements of the page are doing. Also, I talked about A/B testing earlier. consider doing an ongoing A/B test of the live script for conversions or whatever metric you're measuring for your business. So again, just seeing what the script is actually providing to your page on the cohort of pages that include the script versus what the script is, what benefit it's delivering on. Sorry, I lost my train there. Let me see. Anyways, upshot is no excuses. Monitor your pages. And then make sure you're giving feedback to all of your third-party providers. And this is something that gets lost. We complain about third-party scripts, but how many of us actually pick up the phone or send an email to the people who build the scripts and say, like, hey, we like what your script, every other aspect of its functionality, we like what it can do for us, but we're not fans of what it's doing to our pages. Because you have to bear in mind that building a script is like building a web page. You're working in this pristine lab environment where everything functions perfectly and, as things do inside the lab. Oh, sorry, wait a second. I got ahead of myself. There we go. So this is our pristine lab environment. You may or may not wear a face mask when you're doing your work. But we need to be mindful of the fact that this is the development environment. And then this is the real world. Once a third-party script is loosed on the world, the provider can't monitor your pages for you. They're only going to know how their script performs in the world if you give them that information. You need to ensure that when you're talking to them that you are helping them to realize that they need to prioritize performance and that, again, having a meaningful SLA that actually has some teeth to it is really important for you. And then just going to wrap things up. Know when to pull the plug. Outages happen. You shouldn't pull the plug just because the script goes down once. But if you're constantly experiencing outages and slowdowns from a single script, your third-party provider isn't responding to your concerns, then you need to really consider the value in keeping that script. And this takes you back to step 3, where you're researching a new provider. But that's not a bad thing. Web development is iterative, and this is just another part of that iteration. All right, so I'm done with my part of the talking. So now, if anybody has any questions, I'm just going to check out our Q&A here.
Thanks very much, Tammy. We do have a few questions that are coming in. So, folks, we are at Q&A. Please, if you have a question for Tammy, open your group chat, type it in, send it in, and we'll take as many as we have time for. Are you able to see the questions, Tammy?
I am. I see 2 so far.
Okay, and there's a refresh button. You'll see a refresh button. If it turns red, just click it, and that will give you a fresh load of questions.
Oh, gotcha. Okay, I see it now. So I'm reading a question from Klaus. It's surprisingly hard to get people to pay attention. I get the question if those kinds of numbers, like 2-second delay, actually really mean 14% lower conversion. So where do we get numbers like this, and who to believe? I think actually somebody else had asked about the source for that slide as well. I'm just going to go back to it. There we go. So this actually comes from independent research from Aberdeen Group. They're not a vendor. They surveyed hundreds of businesses with revenues with the higher end of the revenue scale, and this is an average number that they got from their survey. So Aberdeen is a very creditable research organization. So I give their research a lot of credence. In terms of your own pages, I mean, I could do a whole other session on how to use tools, a tool like Google Analytics to kind of do your own sort of A/B testing or your own way of finding out, if our pages are slower, how does this affect revenue, how does it affect page views, and that sort of thing. Actually, this is just made me think. I have some older posts where I've done just that, So yeah, I think I might actually rework that post and update it and bring it up, because I can appreciate that just because it's sort of old hat to some people, being able to do proof of concept for page speed equals more conversions is still something that a lot of people need to work through, and being able to personalize these findings to your own site are actually really, really important. So thanks for the thought, actually. I don't know if that answered the question, but it's given me food for thought for a blog post. Let me see. Okay, so a fan has asked, what is your opinion on adding an onload event handler to load uncritical third parties when everything is ready, like recommended here? And he has a link to a blog post. I can't really respond to that because I haven't, without reading the blog post. So what I can suggest is that, because I think I'm going to need to read it and kind of think about it for a little bit, is I'll be posting something on my blog, Web Performance Today, after this, within the next day or so. And you see the URL in the slide. And I will answer that question on that page. So if you want to follow me there, follow me on Twitter, and I'll post a link to that post. Post a link to the post, yeah, whenever it goes live. Let me see. I'm not seeing any more questions. Oh, and now I am seeing another question. Oh, okay, so that was Klaus asked, what is the source for the 1 second equals 7% lower conversion, et cetera, and that's Aberdeen again. So if you type in your own version of, if you Google Aberdeen 7% decrease in conversions, you'll probably find countless different articles out there that are citing this post. Sorry, I can't push out the link in real time to you, but I would just recommend Googling it, and it's you can read the original research that it comes from. Let's see. I'm not. Klaus asked, regarding defer methods, what about script async? And I'm not sure I understand. Do you mean script async? I'm assuming maybe that's a typo. Yeah, I mean, I think that I sort of addressed that earlier. I'm not quite sure I understand the question. Sorry. Let me see. So Christopher asks, are deferred/async scripts a new feature? That is, what's the support for older browsers like IE8? That is a good question. I tend not to really do too much thinking about older browsers. I sort of focus on whatever the most commonly used browsers are at any given moment. So I don't know the answer. I want to say that IE8, if I recall correctly, does not really offer great support for async. Deferral is just deferral. I mean, that's just how you build your page, so that so that when you're the deferred content loads last. But I'll look into the IE8 question, and I will make note of it. And probably, I think what seems like what's going to happen is I will look at all of these questions after the session, and I will incorporate the answers into my blog post. And Ronald asks, what can be done about third-party injected scripts not originating from our websites. I'm not quite sure what you mean by that question. Can you rephrase possibly? Does anyone have any other questions?
All right, Tammy. I'm not seeing any additional questions coming in. So with that, folks, we're going to say a very big thank you to you, Tammy, for spending your time with us today and for sharing all your knowledge and expertise.
Thanks so much for having me. I really appreciate it.
Folks that attended our webcast, we thank you for attending and hope you benefited from it. And we did have people from all over the world joining today, so we thank you if you stayed up late or got up early. And a thank you to those of you that sent in your questions, because having your questions adds so much to our events. As we close out the program, folks, I just want to let you know that I did push out some information to you in your group chat. Tammy is going to be speaking live at our Velocity Conference, July 20th through our Velocity Conference in Santa Clara, California, June 24th through the 26th. And please check out her session there if you're able to go. We've also pushed out a code to you to save you 20% on your conference registration, and we do hope you take advantage of that. Again, it's going to be June 24th through the 26th in Santa Clara, California. Thank you, Tammy. Thank you, everyone. This will conclude today's event. Goodbye, everyone.
Bye. Bye.